Hi everyone, so my name is Anwood. You can call me by my Thai nickname as well, that's O. So I represent Ream team today, so I'm the coordinator for the Ream team. We have a few members, Kobe, Ji-Hun, and Jun in the audience as well, so feel free to come up to us to discuss more. Just quick update, so basically we are Ream Labs, so we are globally distributed, Rust-based, primarily focus is on building the Beam client. We have 3 tracks of work. I'll mention a bit more later on. We are globally distributed, as I mentioned, because we are living in 5 countries across most continents. Ji-Hun and Jun are in South Korea, Kaden, Kobe, Sharik, and Pat Chilis are in Canada. I'm based in Bangkok, Thailand. Varun is based in India. Partha is based in UK, so very globally distributed. There's a few channels that you can follow us, GitLab, Twitter, HackMD, and also Telegram. So I just want to start off with our roadmap when we started off our team early 2025. So we basically thought that Beam specs is coming up. It's a year from having a Beam spec, so maybe we start off something simple and something that is manageable. So we were focusing on maybe our first milestone would be P2P, second milestone would be CK transition proving, and so on, right? Pretty basic, pretty straightforward. But after getting a few months into the progress, the scope got much bigger. So we are now basically doing about 3 tracks. The first track is basically building a minimum Ream beacon client implementation. The second track is prototyping Beam features, and our third track is basically creating Beam awareness and go-to resources, and also talent building in terms of protocol engineers. So track 1, I think our main output here is our Ream client. So it's a Rust-based minimum beacon client. Our objective here, 3 prongs. First is we use this code base to train up new consensus client engineers. It's also the test bed for Beam chain features. So a lot of things that we are experimenting with, the Beam specs or the research that are coming out will actually require some code base to test against. So this beacon code base helps a lot. And thirdly, we could potentially use this during the actual transition or the actual hard fork that could happen. We could potentially use this code base as the one that's running as well. Our progress so far, so we have developed the full beacon STFs up to Pectra. A lot of the P2P code are in place, not complete of course, but most of it are in place right now. The validator progress is also mostly done. I think we are aiming to actually try to run the validator by connecting to other CL clients in the next probably a month or so. And the near goal is basically to build this beacon client so that we can run it on DevNet and testnet as soon as possible. And you can see all the code base here in that link below. The second track is Beam feature prototyping. Basically, the objective for this track is doing early engineering experiments with Beam chain features, feature candidates. Our progress so far, so we have been able to do per operation Ream STF on SP1. So by what I mean by per operation is you have process block, and under process block you have process attestation, process block header, and so on. So we are actually able to run those process attestation, process block header inside CKVMs, and those are SP1 and RISC-0. We have also implemented 3SF implementation in Rust. Hopefully we are able to kind of convert those state transition functions into CKVM as well, so potentially we can do a snarkified 3SF version as well. Another progress is that as we build the beacon validator client, we figured out there's a lot of the components that need to be hashed out for the Beam chain. For example, we are drafting in an ERC for quantum secure key store format, because I think current key store format uses not quantum secure encryption, so we are working on a draft on that ERC. Some of other near goals is that we want to run the complete beacon STF on SP1 and RISC-0. We have already benchmarked those type operations as well. And yeah, so basically the other thing is 3SF mini in CKVM. All of our work are open source, so you can find out all the implementations for CKVM, for SP1, for RISC-0, also the 3SF mini, and Also, we are also maintaining developer notes. So for whatever challenges we stumble upon or took like quite some time to fix or find a workaround, we also write our dev notes here. So you can follow all of our progress here. Our third track is basically beam chain awareness and talent building. So basically, we want to attract new talents to protocol engineering in general. Having more people pay attention to the consensus layer, help build new things. We want to build up open and comprehensive knowledge base for the beam chain. So we built this beamroadmap.org. I think it's being used pretty frequently. And also we want to maintain the go-to resource for onboarding new engineers to beam chain effort. So the progress so far in terms of like the code base, so for Ream, we are actually having 28 contributors. So it expands a lot beyond our core team members. And if we count all our repos, including like all the CKVM benchmark, study group, and so on, we have 38 contributors so far. And in terms of like the Beam roadmap itself, this is the first time I share the numbers. So far we have launched this for 70 days. We have had 1,000 unique visitors so far, about 1.1K total visits. So that's around 16 visitors per day. Right? It's not a lot by, if you compare it to like big websites, but knowing that there are like 16 people who are interested in beam chain and coming to visit and actually use this resource I'm very happy with that. So near goals is keep growing the interest here and also keep the website up to date, especially from all the content from this event. Yeah, and these are some of numbers. So our Ream repo, we had 96 stars so far. We have opened over 338 pull requests. I think it's more by now. 38 contributors and also 200 issues closed. And these are all of the members that all the contributors have contributed to Ream and all the repos that we have. So I think that's about it, our update. So to find out more about us, all our code is on GitHub. You can follow our status updates. We have weekly status updates. The summary is on Twitter. All dev notes are in HackMD, and if you want to chat more in the group, we have a public group in Telegram there. Yeah, thank you.
It sounds like for both teams, building a Beam client is not enough, right? One is kind of tackling the execution layer, and you guys are tackling the beacon chain. How much work would you say is being allocated to the Beam project specifically?
Right. So I think we can go by like the number of people working on it. Our team is roughly more or less like 6 people right now. I think we have about 4 people working on the beacon client implementation, and then 2 are more on like the CKVM stuff. And actually, just to add on a bit to that, I think like there are some interesting stuff that at least for us is interesting to do both like the beacon client and like more beam chain stuff together. For example, like in order to do these like CKVM stuff, like we figure out like there's a few engineering challenges that we need to answer. For example, let's say like you have host and guest machine for the CKVM, right? And you have like this like really huge state. Where do you actually decide to serialize and deserialize the data from native Rust structs into SSE, right? And that impacts the performance, right? You can either like deserialize in the host or deserialize in the guest itself. There's some pros and cons, so being able to figure that out, I think, is important for us. For example, like we figure out, actually deserializing inside the guest machine itself is more useful because then, in order to verify like the Mongo tree, doing the proofs and all that, you'll require the SSE format, not just like the Rust stuff, right? So doing that inside the CKVM, even though like there's some performance difference, the benefits is a lot more. Some other stuff as well, for example, like there's on the SSE level, there are multiple libraries in Rust that are, you can use like SSE inside, but it turns out that they all kind of like prime for beacon chain. And beacon chain doesn't have CKVM, right? So like some of the assumptions, for example, like if you are going to do like the hash, the Mongo tree hash root, I think all of the client implementations right now basically just rehash or re-memorialize everything every time there's a state transition function, and that's not possible to do inside the CKVM because that's a big preference string. We could use like SSCD, like partial updates, and a few more tricks, but then those are actually part of, like, some of them are actually part of the SSC specs, but I think no one actually took care of like actually implementing those parts. So finding those things and actually deciding to whether, are we gonna have a workaround around that, or are we gonna reuse something? I think that's some of the engineering questions that we actually discovered by actually implementing the beacon client and plugging it into like beam chain features.
I mean, REST0 was able to snarkify a beacon client, and my guess is that it's not even using the partial update. So maybe there's a massive speed up that REST0 could get just by doing partial updates.
Yeah.
Okay, any last questions? If not, thank you so much.